Hello and welcome to the Screencast. Today I'm going to solve some of the problems you might see on tomorrow's quiz on rational exponents and higher order radicals. In the first problem here I'm asked to rewrite an expression in radical form. When I do this, I take the denominator and that becomes the index of the radical, and the numerator of the exponent becomes the exponent of the radical term. So for this one I'm going to be left with the fourth root of 10x to the third power. In the next problem I'm asked to do the opposite. I start with radical notation. I'm asked to rewrite in exponential form. So to do that, the index becomes the denominator of the exponent, and the exponent stays pretty much becomes the numerator of the exponent in the rational exponential form. And now because I have an exponent in the denominator, if I put it up in the numerator, I need to make it negative. And I'm all set. Alright, I'm now asked to simplify an exponential expression. So I'm going to use the rules of exponents. So the first thing I'm going to do here is apply the power of a power rule. So when I do that, I multiply the exponents together. That gives me a to the negative 2. And now I'm going to use the product rule to combine the repeated bases. So to use the product rule, I keep the base and add the exponents. Well, the exponents are negative 2 and 4/3. So to add those two together, I need a common denominator of 3. So I need to multiply the negative 2 by 3 over 3. That gives me negative 6/3 plus 4/3, which is negative 2/3. So that means I'm up to a equals negative 2/3. Now, I don't want negative exponents, so that forces me to move the a to the 2/3 down into the denominator, but I also don't want a rational exponent in the denominator, so I need to look at the 2/3 and say what's the next biggest integer. Well, that would be 1, and what do I need to add to 2/3 to get 1? 1/3. So I multiply by a to the 1/3 over a to the 1/3, and that gives me my final answer, which is a to the 1/3 over a. Alright, once again, with this one I'm going to apply the power of a power rule first, giving me n to the negative 5/3 times n to the negative 1/2. Then I'm going to apply the product rule and add the exponents together. So now my exponents are negative 5/3 and negative 1/2. So for the first one, fraction, I'm going to multiply by 2 over 2. And the second one I'm going to multiply by 3 over 3. That's going to give me negative 10/6 minus 3/6, which is negative 13/6. So that means I have n to the negative 13/6, which is equal to 1 over n to the positive 13/6. Now, since I don't want I can't leave a rational exponent in the denominator, I need to look at the 13/6 and decide what the next biggest integer is. Well, 13/6 is 2 and 1/6, so that means I'm going to need to multiply by n to the 5/6 over n to the 5/6, because I have to add 5/6 to 2 and 1/6 to get up to the next highest integer, which in this case is 3. So when I multiply, I end up with n to the 5/6 over n cubed, and that is the simplified version of the expression that I'm looking for. Alright, now I actually have an exponential equation that I need to solve. And the first thing I'm going to do is isolate the term with the exponent. So in this case, I'm going to divide by -4, leaving me with 4p to the -1/5. And that's equal to 1/2. Okay, now, once I have the term with the exponent isolated, I'm going to raise both sides of the equation to a power equal to the reciprocal of the exponent. So that reciprocal would be -5. So that causes those exponents to disappear, and now I have 4p equals 1/2 to the -5 power. Okay, I'm going to follow the quotient rule here and distribute the -5 in the numerator and -5 in the denominator. And now I'm going to use the negative exponent rule. I'm going to bring the 2 to the -5 up into the numerator. It becomes 2 to the +5. The 1 goes down into the denominator, and I'm left with 2 to the 5th over 1 to the 5th. 2 to the 5th is 5 2's multiplied together, and that is 32. So now I have 4p equal to 32. Then I just divide by 4, and I get my solution of p equals 8. First secret word tonight in the sentence is y. Okay, now I'm asked to simplify an exponential expression. So the first thing I want to do is do a factor tree. So 2 times 96, I know I can divide by 2 and get 48. I happen to know 48 is 16 times 3. 16 is 4 times 4. And 4 is 2 and 2. So that gives me 2, 2, 2, 2, 2, 5 2's and a 3. Second word in the secret sentence tonight is the word is. Okay, so I can write 96 as 2 to the 5th times 3, and that's 8 times 4th root of. Now, because I'm talking about the 4th root, I'm going to rewrite 2 to the 5th as 2 to the 4th times 2, and that is times 3. And now I go through and take out any base with an exponent of 4, and I write it outside the radical. And then lastly, I'm going to multiply the 2 and the 8 together and the 2 and the 3 together, and I get my final answer, which is 16 times the 4th root of 6. Next word tonight is the word the. Alright, now I have an expression with variables to simplify. So I pretty much do the same thing. I need to do a factor tree first, right offhand, and I can tell 243 is divisible by 3, which is 9 times 9 is 81. So I get 243 is 3 to the 5th power. Alright, now I look at the index. The index is 4, so that means I'm going to need to rewrite the radicand in terms of things of the 4th power. And next word tonight is sky. So 3 to the 5th I can rewrite as 3 to the 4th times 3, and into the 6th I can write as n4 times n to the 2nd. Now I go through, if I see anything with an exponent of 4, cross out and write it outside the radical symbol, and then that means I have -9n times the 4th root of 3n squared. and I'm all finished. Alright, and in the last problem tonight, I'm multiplying two radicals together. Now these are just square roots, so that means they have an index of 2. So when I multiply them, I'm going to multiply what's inside the radical symbol with and what's outside. Now there's nothing outside except a -6, so that's just going to stay the way it is. And the 8m cubed times 3m squared gives me 24m to the 5th. Okay, so let me do a factor tree of 24. I get 4 and 6, 2 and 2, and 2 and 3. And the last word tonight is blue. Alright, so because I'm talking square root, then I'm going to try to write things in terms of bases to the second power. So since 24 is 2 cubed times 3, I can write that as 2 squared times 2 times 3. And m to the 5th can be written as m2, m2, m1. Now I'm going to go through wherever I see anything with an exponent of 2. I write it outside the radical. And then lastly, I'm going to multiply the -6, 2 and 2m's together and get -12m squared times the square root of what remains, 6m. And I'm all finished. I don't need to write 2 as in the index. It's assumed that it's a 2 if you write nothing at all. Alright, hope you found this screencast helpful. Have a good night's sleep, stay dry, and we'll see you tomorrow. Cheers.